And we have quorum. All right, so today our agenda topic is to have Vipin lead us through Dash technical discussion to supplement what we discussed with Dan Daly last week around what components of IPDK could come into OPI to augment Dash or help Dash out and give us a basis for starting the technical collaboration as opposed to just discussion. Anyone else have any agenda item? Or any other topic? All right. So with that, the floor is yours, Vipin. Let's discuss any and all parts of Dash and how it ought to relate to OPI, or OPI should relate to it. Take it away.
Yeah. Thanks, Joe. Can you allow me to share?
Of course. I will stop sharing and I'll set it so that everyone can just share.
Okay, awesome. Thanks. Okay, can you guys see my screen?
Yes, it's coming through.
Great. It won't take this long, but regardless, let's start having some discussions on Dash. AMD is quite involved in Dash effort, so this is coming from having done maybe hands-on experience that we have in the Dash community. Just to recap, in my understanding is that Dash motivations were to reuse existing Sonic software infrastructure, which includes the entire stack, and I'll discuss that a little bit. But the other motivation was to provide, disaggregated services using the Sonic infrastructure, and they use the term disaggregated because they are not co-located on the host, even though Dash says this architecture could be used on a standalone NIC, but the primary use case seems to be the one for either a disaggregated appliance, which is what I think Dash stands for. And so I think, therefore, this is mostly a bump in the wire for appliance and a switch, leveraging BPUs in line. And those things are really bump in the wire, means they're mostly for networking. The next thing is that there is a thing called SCI API, which is the switch abstraction API that used to exist in Sonic before. And Dash community has really created something which is called Dash SCI, which is an abstraction layer that is defined by the Dash community to be vendor agnostic layer that everyone can plug into. We'll look at how that fits in, but that's the main motivation, is to create the Dash SCI APIs, and both can coexist. SCI can configure the switching layer, and Dash SCI could configure the stateful services for disaggregated network services. And the last motivation was that ultimately Dash APIs are generated from behavioral model, and this behavioral model really is defined in P4. A P4 definition of data path is what then results into how the Dash SCI API looks like. And I have references to various things in the appendix here, if anyone wants to look at what gets generated, or if time permits, we can look at those things here. So these were the motivations for Dash effort. Feel free to stop and ask me any questions if there's anything. Let me see. Is the font and everything big enough, or do I make it bigger than this?
No, it's quite fine.
Okay, if I go into slideshow, can you guys see it? Like, for example, now?
It's still quite fine.
Okay.
It was good before and it's still good. So you can run whichever mode you prefer.
Okay. Okay, because the upcoming pictures will be even narrower. So I was hoping to.
Drop it in presentation mode, and
Okay.
that works just fine.
Okay. Awesome. Okay, so let's look into the Dash software stack. And when I call Dash software stack, this is really Sonic software stack where Dash is trying to fit in here. Um, and the overall model is there are like 3 or 4 layers of this entire stack. At the top, we see SDN controller, which is really defined as network management as a service, which means it's really a distributed control plane that is making API calls into an individual card or an appliance to achieve whatever is needed cluster wide. And so this is out of scope. This is owned by out of scope of Dash in the sense that this is owned by the cloud provider and likely not something that that we need to we worry about in Sonic or in Dash efforts. The main thing that we look at here is the JNMI container, which exposes the JNMI APIs, and these are really the gRPC-like APIs that gets called in from NM as a service, and then it will in turn call various other things in order to translate the state and ultimately program the data path. And so keeping it very simple, there is a stress layer which is with state service, and this is really the one that would take all these higher level user configuration and translate that into a database. And there is a prescription for using Redis database to save all the state inside the uh, inside inside the inside the Sonic device. And so the switch state or in this case switch state could save the stateful services as well. So for anything related to Dash will also get saved uh, in the Redis database through Swiss API conversion. And then from here, there's another process that would read all this data and then call the SI APIs, which is what I think this bottom layer here is. And and that API is the one that will then, when they say technology provider, this is basically the DPU provider that could leverage. I took this picture as is from the reference mentioned here from the Dash website, but the main goal here is to standardize the API, which is going to this SDK provider or the DPU APIs, which are exposed using the SI Dash APIs or SI APIs both combined. And then ultimately what gets programmed from here down to the ASIC or hardware is really something that is called SDK or vendor SDK. So what are the salient points of this stack? Let's recap that very quickly. Basically, it proposes running all or part of the Sonic stack on DPUs. When I say part of, because this discussion is going on whether we should run the entire stack or whether we should run part of it on the DPUs. Even though the picture shows that the goal is to run the entire stack on DPUs, and you could run entire stack on DPUs, but there are trade-offs, and we'll look at that. But there is some I would say acceptance to not running all of it on DPUs, and therefore I mentioned that it basically proposal is to run all or part of it on DPUs, and the target implementations as we talked earlier is smart appliance or smart switch. So which means the DPU is really not directly programmed by network management as a service controller or SDN controller. In the initial prototyping and the rollout of Dash-based products, the goal is to use it for the appliances or smart switch versus a standalone DPU. Scale is really, really high, and one could imagine why this could be because it is aggregating a set of devices in an appliance which is residing outside this. There's a paper that was published by Microsoft and AMD uh, on the disaggregated services and the motivations and all that. I encourage everyone to read that. But from the scale point of view, it is going into tens of millions of connections, and therefore like large number of policies and all those things to be um, to be handled by this piece of software. There's a reference here which describes this kind of scale here. So Dash and Sonic is a very prescriptive stack. There is a layer of operating system and the software layers, various modules, the inter-process communication, data stores and the tools, and everything is like very prescriptive. So it's good in that sense that at least there is less room for wiggling those things. But at least that's how Sonic and Dash defines it. And then, as we discussed, it defines the GNMI not-bound interface. These are gRPC APIs at object level, and it defines the southbound interface to the DPU vendors that could then implement the libsci or the libsci dash API. Any questions so far?
Yeah, so let's talk about the scale. So tens of millions of connections per DPU or for one cloud gateway cluster, right? Because the main use case that they've shared, and it's in their GitHub documentation, and I talked to them about it a long time ago, is they're trying to build a essentially combo of load balancer and tunnel termination and effectively NAT translation, although it's a little more complicated than that, in between an interior cloud of a cloud network and the public internet. They also talked about the use case inside of the servers in that cloud boundary, but kind of one of the main motivations for Dash was this cloud gateway use case. Where again, you're using DPUs as packets in, packets out. So tens of millions of connections per DPU. Have you done the arithmetic on what that really means in terms of the DPU memory footprint, in terms of the ARM processor requirement, and in terms of just the raw bandwidth per connection that can actually make it through a 100 gig DPU? I guess we could do 100 gig divided by 10 million to get a sense of that scale. And
yeah,
does that actually all make sense? I guess I'm asking for sort of a consistency check on whether their request makes sense on a per DPU basis, or if this is just, hey, tens of millions of connections through a set of DPUs, positioned for this particular spot in the cloud gateway.
Right. I think it's a great observation, Joe. Is that is first of all, is this number achievable, and if so, using what? And this kind of discussion has definitely happened in the Dash community. To answer your question, my understanding is that this is the target for a given DPU. And we'll get into a little bit more about how many DPUs could be there. It's somewhat flexible right now. The real products have anything ranging from 4 to 16 DPUs on an appliance, or depending on the smart switch form factor that you are building around it.
Yeah.
So
yeah, I mean the smart switch is 4 or 8 DPUs.
Yeah.
Depending on the details.
Correct.
And chassis, you could probably put 16 of the things in without much trouble. You might be able to put 32, but you definitely could put 16 without a lot of trouble, because 16 times 80 watt nominal is 80 is within the realm of what you can power in in a kind of a 2U box, which is what
Correct.
you would need.
Yeah, yeah. No, so I mean, the scale number is somewhat ambitious too, to be honest. At the same time, it depends on what all functions you are enabling. Usually, scale is not unidimensional; it is multidimensional. What about other things like tens of millions of connections with millions and millions of policies and millions of forwarding NAT, IPsec, and what else is going on, and do I throw storage in this whole mix as well? So ultimately, it comes as to what is that multidimensional thing that is out there,
Sure.
and
No,
so
point.
so this is the goal. I'm saying that the reason this number has been put is not to not to squarely target that as the first incarnation of the Sonic Dash thing, but it is a goal that has been put in by the Sonic Dash community to keep in mind what level of scale that this stack needs to target, both from the configuration point of view and data path and the performance of the software stack here. So let's just use that as a cue for now. Clearly, initial products have gone into numbers that are looking in millions. And like I said, scale is a very subjective thing, especially when in a real product when you try to do all things there.
Yeah,
Um,
and the raw arithmetic comes out if it's 10 million and 100 gig DPU, it's an average of 10 kilobits per connection, 10 kilobits per second per connection on the average, right? And yeah, they're not all going to be active at the same time and so on, but that ain't much bandwidth in the modern world. Like, I don't know if you could even, I guess you can run text chat over that, but you can't do much with that.
Yeah, no, I think it doesn't have to be all coming from one server. By the way, it is going to aggregate things from multiple servers into DPU. In which case, it is possible to have higher bandwidth. First of all, it does decouple the server bandwidth from that of the device, a DPU device. Like the initial product that AMD worked on for this is a 200 gig device. So I wouldn't call it exactly 100 gig device. That's first observation. The second is that these connections are coming in from multiple servers, so that's why the scale is higher. In which case, you can actually aggregate multiple servers to be terminated on one DPU here,
Oh
as
no,
compared to that.
so I totally get it.
Mhm.
What I have is a cloud data center with a whole bunch of clusters of servers, and
Yeah,
that's big scale, right? And I
correct.
have coming into that the rest of the world. I mean, literally the rest
Yeah,
of the world.
yeah, yeah,
What I'm,
yeah.
because this is again, Microsoft is not doing this out of charity. They want a solution for Azure Cloud Gateway where
Absolutely.
they can take best in
So
breed.
I want to comment on that part as well. Is this a solution for a cloud gateway, or is this a solution for within data center? And I would beg to differ from you. It is not cloud gateway solution. The initial use case, if you go through the Dash website, and we can
Huh?
go over that initially now itself, it's documented very well. It's basically VNet to VNet forwarding. What they call VNet to VNet forwarding is really the within data center forwarding, which means bread and butter tunneling, security policies, and uh, and um, and virtual private cloud, which they call virtual networks. So
So they've
it's
back. Okay. So they've backed also because again, it was that as well, but that's a subset of the cloud gateway use case, right? Because the cloud gateway.
it is, but that's the initial target.
Oh, okay. So they
So
backed
this
off. Got you.
correct, yeah. The gateway is a use case. They have identified 4 use cases. VNet forwarding, which is within VPC forwarding, is considered the most primary and the simplest of all, which is what I think the folks are targeting right now. And in fact, that is what the initial implementations are dealing with. So cloud gateway is more complicated than what we have right now. Is all I can say.
Gotcha. Okay, cool. Yeah, we
Right.
can continue. I got you. And again, you're right. There were that the Dash APIs have, I agree, a set of use cases, and if they're starting simpler than when they first, or they're saying our first thing we need to close on is simpler than their original release, which is good because their original thing was really a challenge. So okay, cool.
Correct. Well, I think, and it is not that we are starting with simple means that simpler part is not a use case. It is a valid use case, and I believe Microsoft has announced a product around high capacity instances based on that. So it is as real as it could be. It's not a theoretical exercise, that's all I could say. Anyway, I think there will be we can always invite Dash people or participate in Dash community to know more
Right.
here, right? Let's get to a little bit of. Sorry, was there a question?
Yeah, no, I just want to make one comment right before we move on. I think there are a couple of things Dash may be mixing, even though it's a community. It started by Microsoft, and there is a little bit of a vendor selection and their current and future requirements that are mixed in. What it means is we may not have to take all of them as is. Like you mentioned, right? The size of Sonic and using Sonic on the DPU is a choice they made. We have to pick and choose from there.
Absolutely. You are spot on, Venkat, and that's where I would like to drive as an OPI community. We should understand what Dash is and where it is going, and then we should make our own decisions based on that. Yeah. Absolutely.
Yeah. So again, if you allow me, just one more comment, right? And then the scale part is fine, but I just want to comment on the multi-dimensionality. I think even at 10 million, the baseline connection tracking is kind of scary number. These things are miracles that I know you guys are doing some good stuff, but anyone who's seen or tried to do connection tracking, I don't know, 20 years ago, basic.
No, TCP. It's not just the number of amount of state that you need to maintain and all that, and then you throw the high availability and
I agree.
and things like that doesn't make it easy. And the API layering needs to really scale to that level as well. Like in order to push the policies that are in millions, I mean, you have to have a software architecture that could really take that in. At the rate at which you want to configure and reconfigure policies. This is a massive thing. And DPU is a very supposedly not a super powerful computer that is handling it.
Well, and how much memory do you have on your DPU?
It ranges. I mean, you could go from 32, 64 gig to higher if needed, but I think we are targeting to do this with I believe 32 gig or 64 gig. I'll come back on that number.
So I mean, typical is, I believe, 16 or 32 gig.
Yeah.
And across the board. And that, tens of million connections at 32 gig. I mean, it's not that part's not terrible for tracking the state.
Yeah.
I'm more worried on the bandwidth and the ARM core capacity, and then can the offload engines be configured for that many connections? Like
the disjoint use case here, Joe, is that DPUs are scaled with memory and ARM performance for serving their local host workloads. This is trying to build an appliance with thousands or more servers behind it. So you're seeing a disconnect in scale between those two.
Well, there is and there isn't, right? Because again, I put an array of DPUs in to get whatever aggregate bandwidth I need. And the question is, what is the scale of the state? Okay, so we'll put a pin in that.
I would claim to do that. You shouldn't buy commercial DPU cards. You should buy DPU silicon and build your own cards and throw down hundreds of gigabytes of DRAM with them.
Yeah. I think we need to separate these two, right? I think
the key word on this slide is smart appliance. They're building a smart appliance, right?
Well, they're asking. Okay, so Dash is specifying protocols and essentially acceleration functions as P4 to do tunnel termination and isolation using tunnels of 15 different kinds. They've got this whole laundry list of tunnel types that can come in, and that at least that's what the last I looked at Dash, that's what they were doing, and that was their original intent. What Microsoft is asking for as a consequence of that is that people build them appliances. So they've asked for 4 to 8 DPUs on a switch.
Mm-hmm.
They've asked for essentially an array of DPUs that are completely independent of the server, in effect. I mean, the server's just there to house them, or you could build a chassis. And so they've asked for dense DPU configurations. And then they've also asked for on server, kind of the standard use case we've all been looking at in OPI and where we started. But those other things are what they've been poking around the edges of, and it's some of the implications of the APIs they've built and doing the stack this way, right? Because essentially they want to turn the DPU into a mini smart switch, which has merit. I mean, again, this all has merit, which is why we're talking about it at all and not going, forget Dash, they're never going to go anywhere. This actually all has merit. So does that make sense, Tim?
Yeah. I do have one more question, Vipin. Just
Please go ahead.
side question. So when we think about a smart appliance and it's a rack or a box full of DPUs, in the Dash conversations, when they think about this SDN controller, this NMS out there in the sky, is it touching the individual DPUs, or is it talking to the appliance? And then there's a control plane layer within the appliance that talks to the DPUs.
There is a piece of software that is running on the CPU of the appliance, which could be either switch or just a host running x86 servers. So there is a layer of software which is running on the appliance, and that's the one that is calling into the DPUs.
Although listening to you, Joe, it sounds like they've also discussed just not having that and having the DPU stand on their own, but be commonly housed in a chassis.
Correct.
Guys, we should.
Yeah.
We should. I actually support what Joe said, because we should remember that this is influenced heavily by Microsoft, and they have their own ideas of what they would like to see in their network. And offloading stacks to the DPU is not really high on their agenda, as far as I know. However, it's high on our agenda, right? So I think that we should look at Dash as guidelines that some we can use, some we don't want to use, but
Correct.
ideas of how to do that transition.
Yeah, exactly. All right. So I propose that Venkat, if you have another comment, because your hand's up, but then I propose we drive on through and then we circle back to these topics.
Yeah. I just want to make one last comment. Maybe Ray, is even within Microsoft, right? There are groups that are looking at other use cases. If you remember KY, who used to join us, he is looking at the edge use case. So the scale numbers, we need to keep it aside, because the Dash specification at this point has a lot of this functionality as well as some of the scale. But internally, there are other groups who definitely want to be part of OPI, and then they want us to drive service discovery, and then service chaining and various things like that, right? So even within Microsoft, there are groups that have other use cases. So what we are talking here has always been a different use case. So if we could keep this aside and keep moving forward on what components we can use, we get a reference model, then or a layering architecture. I think those things are very useful to us.
Yeah. I think we all are saying similar things here. Let's dissect in and understand where we want to cut boundaries and or what components make a lot of sense for PI. So let's continue with that. I think those are the exact sort of things that I have at least to be looked at. I'll share these slides afterwards. This is further delving into the details of components without going into all the details. What I want to highlight is that not all components are mandatory here, but there are certain ones that have to be there, like like how user is calling in. It could be GNMI, it could be some form of CLI or equivalent, but ultimately it is coming in from the northbound, which then is processed in and saved into all these, Swiss container, which contains various of these processes for port synchronization. And I apologize for the small font because I was lazy enough uh, to to draw the diagram which is already there in this reference, and so I just cut pasted it. But ultimately, it has basically the port management, orchestration management, the infra work, and various daemons that are taking these APIs and then translating it further into the Redis database. And then from there is one more conversion that happens, which is saving all the configuration into ASIC database, and from ASIC database gets pulled what is called syncd container, which is where I think this side dash API is there. So this picture highlights these two components. There is side dash here up top, and there is side dash here in the syncd container. The goal is to keep most of the components as is, maybe add a few more things in the Swiss container and those things, but reuse this infrastructure as much as possible. So the architecturally, it is containerized for modularity. Each one of these are containerized. So you can, for example, if you don't want to run DHCP server on it, you can omit this container. Same thing with LLDP and SNMP. And I don't know if you would really want to run all these protocols in all situations. So depending on the use case, you could spin up these containers versus omit them. But then there are some which are very fundamental to the to running the entire stack, and the distributions of Sonic has the prescriptions based on the use cases. So Dash community is working on a distribution which makes sense for the stateful services, and therefore I think it is modularized, and we don't have to take all of it. Stateless processes, all these processes are largely stateless, and most of the state is saved in Redis database, or what we call Redis data store. Message bus really is implemented on top of Redis APIs. The message bus really is a way to interact with other processes, and usually this interaction would happen through exchanging the state in the Redis database, and you would get the notifications, and then based on that you will act on certain things. Now, exactly, these are the databases. There is user configuration called config.db and operational state called state.db. And then protocol state is called an application database. And then finally, all this gets, processed up and translated into what is called ASIC-DB. And ASIC-DB is the one that represents the forwarding data path. And that gets picked up by the syncd container, and then the hardware is programmed based off ASIC-DB. And then there is statistics and counter DB, which is also there. Obviously, you need to have metrics and all that. There are loosely coupled processes, and I already talked about how this layer interacts with REST, and SI layer abstracts those things. More details on this reference, but any questions on this slide?
No, this is good stuff.
Okay.
Let's keep
All
going.
right. Yeah, this is not new to many people who already know Sonic, so apologize for the repeat here. But nevertheless, for people who haven't looked at Sonic and Dash Sonic in details, this is probably a good intro to what the architecture looks like. And so I think OPI versus Dash APIs. Now it comes down to the question. There is an option that we can look at this GNMI layer as the standardization effort or alignment with it, or we can try and look at the side dash APIs as a potential way of vendor, as a vendor agnostic APIs that could program the data path. But that's a choice we need to make. Ultimately, what components we take and what piece of software stack here that we need to absorb as part of the use cases we are looking at. So to me, I think these are the main technical considerations for the OPI community. First one is Dash. Dash does allow good reuse of code tools and validations, which components are the ones that we need to bite into, or the ones that are complementary to what we need for the use cases. Also, Sonic Dash Stack is primary for network and network services. This is TBD. I don't think storage has been talked about ever, but we are looking at supporting storage APIs. So do we fit that into Sonic OS, or do we consider something? I believe you could run it. It's just the question of how's that going to fit into this whole equation? Like, do you want to really subject storage APIs to go through the same translation and then the side dash equivalent of things? I don't know if that'll make a lot of sense for networking. I think it is very sensible architecture. But that's a thing to consider. Dash can be heavier. We talked about it quite a bit. There are a lot of processes, and with appliance form factor, it becomes easier to cut this thing and say, look, I'm going to run most of the Redis database and everything up in the user space, and basically augment yourself with the x86 CPU, which is running up in the appliance or a smart switch. But if you are a standalone DPU and you were to run like in a full-blown user space database with multiple entries for various configuration in different databases, then it does come with a cost. I mean, the modularity of architecture is great, but at the same time, I think there is a price to pay for that. So, which components do we want to take, and where do we thin things? And these discussions are happening in Dash community as well. But nevertheless, this is even more important for our use case where we are looking at DPU to be standalone. And then I think someone pointed out earlier that Dash is addressing cloud use case primarily, and cloud use case is I don't know besides Microsoft if there are other cloud vendors participating heavily right now in Dash, although I think the goal is to have more people get involved into the Dash effort. But how about our other use cases like Kubernetes use case we talked about? Is that going to fit in? And if so, is this good enough of API for us to support there? And where to align our OPI APIs, which we are discussing and defining, is it GNMI layer or a SI layer? So to me, I think these are like 4 or 5 considerations before we make our pick on aligning with Dash community. I think that was it, and there are a bunch of references. I'll share these slides with everyone after the call.
Yeah. If you put the link in the chat, I can copy it into the notes right now. So I don't think it's GNMI versus SI. I think we should consider both at the same time. The one thing that wasn't mentioned is the life cycle and provisioning. So
yeah,
we could say, hey, let's group up and let's have OPI define the life cycle and provisioning. Let's have OPI define storage APIs. We could take the stuff Dan was talking about and propose, hey, here's a way we can have a common interface to the SDKs of the DPUs themselves for the purpose of the SI. And again, what you do with it follows what Dash has been saying with how they want to use the SI extensions to talk to the P4 programs that are being defined as the operational tunnel termination definition. And then what we could do is we could say, hey, for all the GNMI tunnel termination APIs that have been defined, what we do is say we adopt those, just like we cross adopt other open source projects. We basically say, hey, for OPI compliance, when you need these tunnel terminations, that's defined over in Dash, and you just use those. Now, for the implementation, OVS is something that, of course, we have to consider. And there's a question in my mind of whether we can take the P4 definitions and the GNMI and we could use that with, say, an OVS or a VPP implementation on the DPU, or if there was a vendor networking stack, so we could we could still use the API definitions and the P4 definition of the behavior model, and then or something like that. I don't know. Other thoughts, Dan? I was going to say you must have your hand up by now.
Oh yeah, no. I was going to say that I think that the best part of Dash is that it's being driven by Microsoft, but it's also the double-edged sword of if you aren't Microsoft, can you take advantage of these APIs? So that I think is the $1 million question. Are others going to want to take advantage of these types of APIs, or if it's going to be something different, which would, use the high connections per second feature of these boxes, these appliances, but potentially would do it in a different way, because you can't really do 10 million updates per second over a gRPC. It doesn't work. So you have to do something local onto the box. So that I think is the big open, and maybe this is an area that we can help expand, which is that this functionality that they're exposing in the appliance is sort of very common amongst all of these IPU DPUs. So if we could start with Dash and figure out how to apply that in a different environment with a different software stack. OVS is a great example of, I think, where it could be done. Then that might be an interesting way for us to contribute. I do think that the biggest issue with Dash is that if it's only for Microsoft at the moment, and other cloud vendors have different approaches, some with Smart Switch, some without. It's a question of who else can be served by Dash.
Yeah, although the general the tunnel terminations they have, some of those do have more general applicability. I mean, some of them are specific to Microsoft Azure internal communications, but many of them have general applicability. And so it's not completely terrible. Murcia?
Yeah, sorry, let me unmute. I have a pull request that I pointed out there. I believe Alibaba also joined the Dash, and they propose all the APIs and the HLD for NAT as a use case that they're very interested in. So that will be another, let's say, company that join. And the other one, as an opinion, I would probably adopt the SAI if it was in OPI, not necessarily all the way the GNMI and all the other layers. Probably SAI. And somebody said something about storage. We could propose storage APIs for SAI and enhance SAI to support storage, and that will be a very good contribution.
Yeah, it's good. Yeah, and so again, on the GNMI, we basically say, hey, we're going to adopt what Dash is defining for the tunnel termination APIs, including the P4 specification of the behavior of those. So at one level, we basically say, if you need this kind of tunnel termination, that's how you do it. OPI is not going to try to redefine, a different parallel set of tunnel termination APIs. We do it the Dash way because they're already defining it, and there's nothing wrong with what they define.
I have a comment to that one. I think tunnel termination is just a side effect of the cloud use case. If at all we are interested in aligning with Dash, it may be okay to say that, look, for cloud use case, let's just use Dash, which includes VNet to VNet peering and within VNet forwarding and outbound traffic and all that. So it may be better aligned instead of saying tunneling, because tunneling for cloud might not be same as tunneling for EVPN use case that we are discussing. For example, if you really want to have MAC addresses being used as a forwarding thing in your EVPN gateway device, then there is also tunneling. So I would say that if there is acceptance to it, we can say, well, public cloud use case that it is for OPI, and we can probably forward or deprecate our cloud APIs against Dash up the stack, as long as we are convinced that it'll work on the standalone NIC card. Fully.
That's a better refinement of the intent. So I agree that, but it's a refinement of the intent. So the intent is that for those tunnel terminations that Dash is defining, we use Dash. For kind of the VXLAN, BGP, EVPN, and those kind of tunnel terminations, we probably continue to define that in OPI. If Dash is also defining those, then we should have a meeting of minds on those. And then anything having to do, like you say, VNet to VNet forwarding is basically tunnel termination on both sides. It's just, which NCAP, DCAP are you doing each way? And maybe we should take a look at what their, kind of what their current proposal is and what they think they're going to propose in the future, and match it to what the network API subgroup has been talking about. And if there's overlap, we go negotiate the overlap. If there's not, we basically say, hey, here's our space, here's your space. And when the projects bleed into each other, we know where the boundaries are in terms of definition, because I think that's a better way to go forward than having overlapping. Because if I was you as AMD, or I was Mike with NVIDIA, or Dan with Intel, I would hate having to do 3 different versions of the same API on my cards and the SDK and my stacks. That would drive me nuts. It's like, why can't I just have one? So I think that's at least my motivation.
Okay. Can I jump in? I just have my hand up. I'm going to jump in. So Dash has an underlay overlay clearly defined. I think we spoke about it earlier, maybe in the API group. Also, that there are certain lower level objects, and as you build these layers of abstraction, there are higher level objects that get built, and then associated APIs. So there are multiple ways we could think about aligning. The underlay, they have defined one way. OPI could extend it, because cloud is not the only layer that sits on top and extends the objects and the APIs, because we have other other use cases, especially like a host offload. So I think thinking about that underlay overlay maybe, and enhancing, defining those layers and the object set at each layer and the APIs at each layer will allow us to kind of separate these things. At the same time, it's almost like you're building multiple stacks, right? I'm saying it a little loosely, because there is a cloud stack at higher layer, at lower layer, the underlay is same between cloud stack and a host offload and some other stack.
Right, good points. Dan?
Yeah, I was just going to agree with what Venkat said. And also, when they're using Dash as an appliance, there's also still potentially a smart NIC on at the edge, right near the VMs. So all that tunneling stuff is happening in a different device. So, that's still, all of that needs to be specified and defined in OPI. So, I really like the idea of using Dash as where there's overlap, just like you were saying, of the use case in the server, and so that we don't have 3 different interfaces. And I think that we can align Dash with the EVPN, the FRR use cases that are inherent to the edge, to the not the edge, the NIC card usage versus the appliance. We just need to nicely merge those together.
Yeah, but good points as well. All right, anyone else? Anyone else at all?
I just want to just tee off one last comment on the life
Sure.
cycle. In Dash community is not too worried about the life cycle issues that we are discussing, largely because they are a bit agnostic right now, especially given the appliance form factor and all that. So the manageability of the device and all that is more tightly controlled than a general purpose server having to manage a DPU either from network or from host. So I'm just saying the part of booting in OS, general purpose OS and all that is very much part of the Sonic effort. So there are elements of lifecycle that Dash community may not care about, but there are certainly things that would make good sense for us to align with them on. Like I believe there is a recommendation to boot a standard distro of is it Debian or Ubuntu that runs on typical distros. I don't know which one.
With Sonic?
Yeah.
Sonic is Debian.
Debian. Okay. That's fine.
Although running Ubuntu is not really an issue with Sonic. Because it's Debian based, but Sonic is Debian. If you try to run a different Linux than the Debian family, you run into quite a lot of problems because Sonic is heavily intertwined with the kernel. So
correct.
We've looked at that in the past, and the Sonic community, again, Linux Foundation Project has never shown any interest in porting to other versions of Linux. Because again, it's a switch OS, so who cares?
Yeah, exactly my point. I think it's more prescriptive in a way. They avoid problems that we are running into by being prescriptive. At the same time, I think it works for the use case. So I think ultimately we need to see if we want to, and especially if Alibaba Microsoft is aligned on making it happen for cloud use case. I think it makes sense for us to look at it if we are either we take the tunneling part that Dan was talking about, wherein how is this traffic reaching the appliance part, or we take this entire thing to run the DPU itself if this is a good feature stack that could run the entire DPU.
Excellent. All right. Murchie,
Yeah, I think it heavily relies also on ONI for booting up the OS. So I think
is it the
ONI
switch OS?
support...
Is it the switch OS or the DPU OS?
I think it's coming to the DPU since DPU will also be based on Sonic. But yeah, for switch different, of course, ONI, and probably it will come also to the DPU.
Well, so yeah, Sonic's loader is ONI.
ONI, yeah.
You don't necessarily have to load Sonic with ONI. If you have something else that can load the Sonic image, then
that is correct. But this is a method that I have seen most of the switches and of everywhere being used. ONI.
All Sonic switches use ONI today. I don't know of one that does not use ONI today. I mean, all the Dell switches that run Sonic use ONI. All of the, I believe Cumulus might run ONI. I mean, pretty much all of the open network operating systems use ONI. What the point is that Sonic doesn't require ONI. It just happens to be the one that everyone used, and it works fine, so they used it. So there is an open question of whether but so I don't think we need to use Oni to load Sonic. I don't think we need to require Oni. It's just a default choice if you're using Sonic, but that's a good discussion to have because, I won't bet a month of my salary on it at this. I'm not at that confidence level, but I believe we can not use Oni. So that's a topic we could cover as well. All right, we're at time. So we'll continue this. I mean, this is going to take us a few sessions to work out. So let's continue this as for part of the time next week. Excellent discussion.